As seen in video 9, estuaries in their natural state are unique and valuable coastal ecosystems. Extremely productive, they are a habitat for large numbers of fish, birds and other wildlife. They filter sediments and pollutants from coastal waters. They provide a buffer against coastal erosion and are a highly efficient carbon sink. Although always highly valued and protected by Maori and attractive to early European settlers as harbours and ports, most have unfortunately been severely impacted and degraded by human activity in the years since. Much of this can be blamed on coastal squeeze, where human use and development has encroached seaward into estuaries. They have been drained to provide farmland for grazing animals, reclaimed or infilled for urban and industrial development, and for ports and marinas, used as rubbish dumps, used as drains for sewage and stormwater, dredged for navigation channels and sand extracted for construction, have had river inflows diverted, cutting off freshwater flow into the estuary, or flow reduced by water extraction upstream, and road causeways have effectively cut off the flushing action of the tide from some areas of the estuary. All these physical impacts have directly and obviously harmed estuaries. More indirect, but equally important, are the impacts on estuaries from upstream catchment areas, the land through which the rivers and streams flow on their way to an estuary. Here, widespread deforestation and clearing the land for farming, exotic forestry, housing, roading and industry has greatly increased soil erosion. In turn, this increases water volume and increases the amount of sediment delivered to the estuary, along with all sorts of nutrients and contaminants, fertiliser, stock waste, herbicides, heavy metals, hydrocarbons and bacteria. As we know, estuaries are natural sediment traps, gradually filling with sediment and changing over their lifetimes. But this increase in sediment, caused by humans, has sped up the sedimentation rate from about 1 millimetre a year before human settlement to 20 millimetres a year in some New Zealand estuaries today. This may shorten the natural life of an estuary. As well, the increased sediment and flow increases the turbidity or murkiness of the estuary water, reducing the amount of sunlight reaching the seafloor. This then affects the plants and plant microbes, which are the base of the food web. Also, plants and filter-feeding organisms like shellfish may be smothered and buried by this extra sediment. This may change the balance within an estuary. For example, mangrove may find it easier to spread beyond its normal range. Let's now look at the other contaminants we mentioned that are carried along with the sediment into an estuary. First, nutrient pollution, primarily nitrogen and phosphorus from agricultural fertilisers and from detergents and sewage, adding to the minerals and nutrients from natural organic matter in the estuary. While all these nutrients provide essential food for plant growth, too much of a good thing, i.e. too much food, can be a problem. This enrichment, called eutrophication, causes excessive growth in underwater plants, algae and phytoplankton. It results in harmful algal blooms, scums which spread across the water and which block sunlight, reduce oxygen and often release toxins, damaging plants, fish and other organisms and generally hurting the health of the estuary. Other pollutants contained in catchment runoff include toxic chemicals such as hydrocarbons from fuel and tar, and heavy metals such as copper, zinc and lead from buildings, roads and cars. These pollutants end up bound in the muddy sediments in the estuary floor and may affect the health of organisms and of humans if eating them. Bacterial pollution can also occur due to fecal matter washed into rivers and streams from livestock and from sewage leaks. This is accumulated in shellfish, making them unsafe to eat, and the estuary water unsafe to swim in. Finally, on a local level, the natural balance of an estuary can be threatened by excessive harvesting of species for either food or bait, and by international shipping, bringing in invasive plant and animal species. Increasing knowledge of natural estuaries and of all the human impacts which have degraded them will help in their restoration and their care into the future. How will rising sea level affect estuaries? As seen in video 3, sea level rise, driven by melting of ice on land and by expansion of warming water in oceans, varies all around our coastline and is currently in the order of 2 millimetres per year. It is generally predicted to be somewhere between 30 centimetres and 1 metre over the next 50 to 100 years. Obviously, this rising sea level could simply inundate and drown existing estuaries, and in some cases this may happen. However, there are two ways estuaries may adapt and survive. In simple terms, they can move up or move in. Let's see what this means. Moving up means enough sediment is deposited on the estuary floor to keep up with the rising sea level. This is called vertical accretion and occurs if sediment supply from both land and sea is increased and then trapped by the estuary vegetation. If the sea level rise is too rapid or the sediment supply is restricted, the estuary may well flood and become permanent open water. Moving in means the estuary migrates inland, gradually re-establishing itself on low-lying land nearby. This depends on whether there is available flat land immediately landward, such as freshwater wetlands or undeveloped floodplains, or flat land previously drained for farming. If the surrounding land is too steep or has been heavily developed, then inland migration will not be possible and the estuary will be lost. In real life, it's complicated. The way an estuary actually adapts to rising sea level varies and will be different for each estuary. As we have learned in video 9, these estuaries are dynamic and complex ecosystems with many interconnected processes, and each estuary is unique. A number of factors will affect how, or even if, an estuary will be able to adapt to sea level rise. The rate of sea level rise, the size, shape and depth of the estuary, the volume of catchment runoff with its sediment and contaminants, and finally, the health of the whole ecosystem, especially of the vegetation. Research suggests that reversing negative impacts and improving the health and biodiversity of an estuary and its catchment area, no matter what future is predicted, will build resilience and the ability to adapt to future stresses.